Hi, everyone. I'm Karen Draxel, and I'll be talking about the Mesoscale modeling effort that we're undertaking to help the team characterize eagle soaring habitat. Of the Wind Toolkit LED development. This stands for Wind Toolkit Long-Term Ensemble Dataset that I'll explain later. And I'll talk about this before John Reedy from the HDF group will give you an example of how you can access the data once they're ready. And now, there we go. So as you know, in collaboration with 3TIP by Vaisala, we developed the original Wind Toolkit a few years ago, which was the most up-to-date and largest freely available grid integration dataset at the time. And that is available for 7 years, providing time series of meteorological variables every 5 minutes and every 2 kilometers across Kronos. And this resolution has been requested by stakeholders. But it suffers from being a deterministic dataset, which means it provides one value per location. And in the absence of widely available measurements, especially at hub height, the modeling error is unknown. And therefore, we're developing an updated version using a new model setup. And we will include model uncertainty this time so that users are provided with a range of possible wind speeds at certain locations. And this time, Alaska and Hawaii will be included as well. And the time series will be available for 20 years. And you see asterisks there on my slide, and I'll get back to that on the next slide. The Wind Toolkit setup is listed here on the right for those who are interested. And I also want to mention that we are delayed in the production, unfortunately, because we have found a bias and unreasonable patterns in the wind speed in the production runs that we have already conducted. And right now we're running again, but as I said, we are unfortunately delayed in distributing the data at this time. Okay, so I'd like to get to the asterisks now. So this is how we're going to do it. We'll produce the 2 kilometer 5-minute data set for 3 years, 2018 to 2020. And I will also leverage a data set that's produced at Oregon National Labs, and that will be the 20-year simulation. That's a 4 kilometer setup, and we'll have hourly output. And then in the end, we'll use machine learning to create a homogeneous data set at 2 kilometers. So there'll be some overlap between the 2 kilometer, 4 kilometer run in terms of time, and this will serve as the training data set. And then we'll use machine learning to downscale basically the 4 kilometer run to the 2 kilometers. And in terms of uncertainty calculation, so we'll run ensembles for 1 year, which we're doing actually right now, since this is underway. So we'll calculate the uncertainty from the ensemble spread of this 1 year of data. And then with machine learning, we'll extrapolate this uncertainty to 20 years, to the 20-year single model run. And here I have a slide that shows you all the variables that we're going to save from the runs. And this table has been discussed in many discussions with stakeholders and has ultimately been approved by the stakeholders. And you see that wind speed and wind direction are the most important one. They are going to be available at many heights. And there are some other variables that will be a subset of heights. Again, there's going to be 3 years of 5-minute 2 kilometers and the rest of the 20-year hourly 4 kilometers before we want to create this homogeneous data set. Also, I want to note that the vertical wind speed here was added to this effort for this project. And so the vertical wind speed will be available for the 3 years at our hourly resolution at 2 kilometers. And with that, I want to pass this on to John Reedy.
Good morning, everyone. So I'm John Reedy from the HDF group. And when this project first started, we thought it advisable to create a data service to access this data. The thing is, these files are so large that it's quite impractical to download them to your computer. So instead, there's a service that you can connect to, and you're able to retrieve any data that you need, basically. So for each of these variables, the array dimensions are, for the old WDK at least, were 61,368 by 2976 by 1602. And using this Python package, you can again slice and dice these 3-dimensional data cubes in any way you want. So you may, for example, for a given geolocation, you want to get all the data covering the continental United States. And that's easy to do in 1 line of code. Or, for example, you may want to get a time series given the current time value and get all the values for those that time range. Next slide, please. So how do you get access to this? Well, the easiest way is to use your NREL API key, and that connects to a server that's managed by NREL. And the only constraint here is that it's a shared resource, and you're limited to 1,000 requests per hour, which should be sufficient for most people. If you're running, for example, though, like a cluster-based simulation, that may be a limit that you'll hit. Alternatively, the HGF group provides a Jupyter Lab environment that actually runs inside AWS. And this is advantageous in this case because it's co-located with the actual data files on AWS S3. And that's a free utility, so you can just go to hgfgroup.org/hgfkeytolab to sign up for that. And thirdly, it's quite feasible to run your own server. So HSDS is open source, and I have a link there that provides instructions for getting started with that. Next slide. So given that, how do you actually use this thing? Well, we have a very comprehensive set of examples on GitHub. So I would start there. Those examples show you not only how to programmatically do things and how the data is laid out, but how to actually connect to the server and so on. And the Jupyter notebooks, I think, are really a good introduction. There's a whole series of Jupyter notebooks you can use. And Jupyter is very nice when you don't quite know exactly what you want to do. You can try out different things and see how that works. And then maybe from there, proceed to a more automatic kind of program. And that's it. I'll hang around for the Q&A session if anyone has questions.